Alrighty, we're moving into the last section of our notes. These are problems. Let's start off with some examples with the power rule. So let's do some derivatives over here. We'll do some antiderivatives over there. So let's do the derivative of 3x to the fifth. Remember, with the derivatives rule, we brought down that 5, so 5 times 3 is 15. Subtracted 1 from the exponent, 15x to the fourth. Now I'm going to do the same idea but going backwards. The antiderivative of 15x to the fourth equals what? Well, we know what the answer is because we're just looking for the function whose derivative is 15x to the fourth. But now I'm going to use my new set of rules. So the first thing I'm going to do is I'm going to take this variable, I'm going to increase the exponent by 1. So 4 plus 1 gives us 5. This 15's along for the ride. And now I'm going to divide by the new exponent. Always have your plus c there. And then when we divide this right here, we get 3x to the fifth plus c. Make sure you don't forget the plus c. Right what we have over here. The plus c is extra, but that just means that if we move this up and down, in the curve up and down, we're still going to have the same derivative. So let's look at a similar one. The derivative of negative x to the third, we bring down the 3, so it's negative 3x, subtract 1 from the exponent, 2. When we do the antiderivative of negative 3x squared dx, what we're going to do is we're going to take this, we're going to increase the exponent, well, the negative 3 is along for the ride, increase the exponent, divide by the new exponent. Always have plus c. Then when we cancel out the 3's, we have negative x cubed plus c. What we started off with. So we'll just follow that through a couple more examples. So let's do the antiderivative of 10x cubed dx. Add 1 to the exponent. Divide by the new exponent. Add c. And we can reduce that fraction to be 5x to the fourth over 2 plus c. That's all that we're doing with that power rule. Now let's look at some of the special derivative rules. These really just have to be memorized. So I'm going to say let's find the antiderivative of sine x dx. Well, here's where we have to remember our circle. Except now for the antiderivatives, we're going counterclockwise. So I go to sine, I see it goes to negative cosine, so this is negative cosine of x plus c. Again, this is one where if you memorize it, it's really straightforward. If you don't memorize, you're completely toast. So make sure you memorize it. Same thing with one like this, the antiderivative of 1 over x dx. We have got to just remember it. It's from this list that we had right up here. Pink, right there. Natural log of x plus c. The final thing that we're going to do is just use these rules that we had up here in terms of what we work with separately and what we don't. We were already using this constant multiple rule for ones like this, where the 15 was just along for the ride, and we added 1 to the exponent divided by the new exponent. So let's work with that last little piece and then we're going to be done. So, combined problems. Let's find the antiderivative of the secant squared of x dx. Oops, no dx yet. I'm not done with the problem. Secant squared of x plus 2x to the third dx. Now this dx tells us where to stop taking the antiderivative. So this whole thing, we could put parentheses around it if we wanted. But this dx tells us that it's sort of like this and this sort of form parentheses, kind of saying, you know, everything in between is what we're taking the antiderivative of. So when we look at this, we're just going to take the antiderivative of this piece and this piece separately. So this is the same as saying the antiderivative of secant squared x dx plus the antiderivative of 2x cubed dx. Notice if we've got two antiderivative signs, we've got two dx's as well. So this one is one that we just have to have memorized. Antiderivative of secant squared x is tangent of x plus c. And then over here we add 1 to the exponent, the 2's along for the ride, constant multiple rule. Divide by the new exponent plus c. And now because these two c's can be any number, we don't know what they are, we don't care what they are, they can just sort of be combined together at the end to form like 1 plus c at the end. It doesn't have to be 2c, it's some number, we don't care what it is, we're just saying that there's some number at the end. If it's two numbers added together, whatever. It's fine having it just as one number at the end. So we reduce this is plus x to the 4th over 2, and there we are. One final problem, then we're done. That was problem 1. This is problem 2. Go ahead and try this one on your own. We want to find the antiderivative of e to the x plus cosecant x cotangent x, and our variable is x. Try that one on your own. Restart the video when you're ready. Pause the video now. Okay, so this is the same as saying we want to do the antiderivative of e to the x. We can split them up. Antiderivative of cosecant x cotangent x. And these are ones that we just have to know from our rules. So antiderivative of e to the x is just e to the x plus c. Antiderivative of cosecant x cotangent x is negative cosecant x plus c. Combine our c's together, e to the x minus cosecant x plus c. And we can always check these by taking the derivative again. So here's my check. The derivative of tangent is secant squared. With here we bring down this 4, subtract 1 from the exponent, and the derivative of any number is just 0. So we should get secant squared x plus 2x to the 3rd. That's exactly what we had to start off with. Same thing down here. We can check it. If we take the derivative of e to the x minus cosecant x plus c, then derivative of e to the x is just e to the x. The derivative of cosecant is negative cosecant cotangent, and the derivative of c is 0, so we have e to the x plus cosecant x cotangent x. Exactly what we started off with.